This is a revision lesson for the trigonometry finding missing sides topic. So let's jump right in. So before we kick off, let's have a quick starter task where we need to find the missing lengths of these triangles. Okay, so pause the video and have a go at finding the missing lengths. Okay, best of luck. Okay, so hopefully you will realize that you had to use Pythagoras' theorem in order to figure these out. So that is a squared plus b squared equals c squared. We can use this with right angle triangles. All right, so for question 1, if you just want to label these sides of the triangle, we're going to call this a, b, and we always call our hypotenuse c, remember. Okay, so a squared plus b squared is equal to c squared. We had a was 12, so 12 squared. B was 9 plus 9 squared is equal to c squared. 12 squared, you can use a calculator for this. If you don't have one, that's fine. 12 squared is 144, and 9 squared is 81, and that had to be equal to c squared. If you add up 144 and 81, you should have found that c squared is equal to 225. Now, to find out what c is, we need to do the opposite of squaring, which is square root. So c is equal to the square root 225. Now c, 225 is a square number, if you happen to know this off the top of your head, and it is actually 15. So in this case, c is 15 centimeters. So very well done if you got that right. If you didn't, feel free to use a scientific calculator, either online or if you've got one at home, use a calculator. Okay. Question 2 now. If we just label up the sides of this triangle, so we got a, b, and c. C being the hypotenuse, remember. Again, a squared plus b squared equals c squared. We said that a was 5, so 5 squared over b squared, or adding to b squared, is equal to c squared. Well, c is 13. And if we solve these, 5 squared is 25. So 25 plus b squared is equal to 169, which is 13 squared. Now, to figure this out now, we know that b has to be equal to, so 25 plus something equals 169. So that must mean that b squared is equal to 169 minus 25, meaning that b squared is equal to 144. Again, you've probably recognized this, that 144 is also a square number, so b is equal to the square root of 144. Therefore, b is 12 centimeters. The square root of 144 is 12 centimeters. You can use a calculator for that. It's not a problem. Question 3 then. If we label it this triangle, we've got a, b, and c for the hypotenuse. Here we go again. A squared plus b squared equals c squared. A was 7, so 7 squared plus 9 squared is equal to c squared, because we don't know what c squared is yet. 7 squared is 49, 9 squared is 81, and all of this, if you add those two together, you get c squared. So c squared is equal to 49 plus 81. That would give you 130. Therefore, c is equal to the square root of 130. And you would have, if you knew this one off the top of your head, amazing. But I'm not. I definitely didn't know this off the top of my head. If you put this in a calculator, you would get 11.401 going. Okay, but you can just call it. We can just call it 11.421 dp. Okay, so and that'll be centimeters. Sorry. 11.4 centimeters. Okay, so very well done if you got those starting questions right. So let's move on to the main lesson now. So we're going to be using trigonometry to find the missing sides of triangles. Okay, so this is trigonometry. If you ever see the word trigonometry or you see triangles, you should start thinking about SOHCAHTOA. These are the trigonometric functions: sine, cos, and tan. So if we want to find the missing length of this triangle here, we need to think about what sides do we have, or do we either have or we're trying to find. So this is our angle here. So if we were to label up this triangle totally, the hypotenuse is the side opposite the right angle. So opposite the right angle. So this is the hypotenuse. The angle, the side opposite the angle is called the opposite side. And the side that is adjacent the angle, we call that the adjacent side. Adjacent is just another word for next to. So we know that we have got O and H because we're trying to find the opposite side, and we know the hypotenuse. So we need to find which trigonometric function has the opposite and hypotenuse. Well, that's going to be sine. So we know, to kick us off, that sine theta is just any angle, equals opposite over hypotenuse, because the SOH means S equals O over H. Sine equals opposite over hypotenuse. If we then substitute the numbers in, so the angle is 30, the opposite is X. We don't know what the opposite length is, but we know the height is 18 centimeters. We need to rearrange this equation so we've got X on its own. And because we're we want to get X on its own, because X is divided by 18, if we multiply both sides by 18 centimeters, we will get sine 30 times 18, and that will be equal to X, because the 18 centimeters will cancel out, okay? So if you get a calculator, and if you just type in your calculator, so sine 30 times 18, you will get 9. So that must means, so if 9 equals X, or 9 centimeters, let's do that again. If 9 centimeters equals X, that must mean, just rearranging it so it looks a bit more sensible, X is equal to 9 centimeters. Job done. Okay, let's have a look at another example. So we're going to calculate side F to 1 decimal place. We're trying to find this missing side. Oh, hello. We're trying to find this missing side here. So again, SOHCAHTOA. What sides do we have? Well, this is our angle. Side opposite the hypotenuse is H. Side opposite the angle is O. And the side adjacent to the angle is A. So we can see here that we're looking at side A and O, or O and A. That is the tan function. Okay, so if we type this out now, or write this out, we now know that tan of an angle is equal to opposite over adjacent. Okay, so if we pull in the numbers now, so tan of the angle's 51, tan of 51 is equal to, opposite is 23, and the adjacent is F. This is our unknown, okay? So if we want to rearrange this, we get F on its own, okay? So one way of doing this is we want to get rid of, let's try and move F over the equation, okay? So we want to get F on this side. So if I multiply both sides by F, that will give me tan 51 times F. And that will be equal to 23, because the F's cancel out on the 23 over F if you times it by F. But now, because I want to get F on its own, I have to divide now by tan 51. I want to get rid of this multiplied by tan 51. So if I divide by tan 51 now, I will get F equals 23 divided by tan 51. Okay, and if I type that into my calculator, so 23 divided by tan 51, close the bracket, press equals, I get F is equal to, I'm just going to write this to 1 decimal place now, F is equal to 18.6 centimeters, and that's to 1 decimal place. Okay, so just having to rearrange a little bit more for these examples. Okay, So let's have a look at one more example now. So example 3 now, we need to calculate side G to 1 decimal place. So again, let's have a think about what sides we know, what sides we're trying to find. So we've got our angle here. Opposite the right angle is hypotenuse. Opposite the angle we know is opposite. And the adjacent side to the angle is A. So if we write down sa, ka, toa, again, we can see we've got opposite and adjacent. So we're going to have to use tan again. So tan theta is equal to opposite over adjacent. Start filling in the numbers. Tan of 12 is equal to 15 over G. So now we know this. We need to rearrange this now so we can get G on its own. Well, because we're dividing by G, we're going to pull G over to the other side of the equation. So we're going to multiply both sides by G. So tan 12 times G is equal to 15. But now we want to get G on its own again. So we're going to get rid of this multiplied by tan 12. So we're going to divide both sides by tan 12. That leaves us with G is equal to 15 over tan 12. And if you type in your calculator, 15 divided by tan of 12, press go, you find that G is equal to 70.6 centimeters, and that's to 1 decimal place. Okay, so here comes the main task. I'm going to move this calculator out of the way for you guys. So pause the video and have a go at these questions. Okay, best of luck. And here are the answers. So let's have a look at the checking question now. So you're asked to calculate the size of angle theta. Okay, so this is the angle here. Okay, so slightly different to the lesson we've just done. So pause the video and see if you can have a go at answering this question. Okay, best of luck. Okay, so let's have a go. So again, we're going to use SOHCAHTOA, SOHCAHTOA. But which function are we going to use? So we need to label up this triangle now, okay? So we've got our angle here. Opposite the right angle is hypotenuse, and the angle we're trying to find is opposite the angle that we're trying to find. So now we know we've got the O and the H. So that means we're going to be using the sine function. So this means that sine theta is equal to opposite over hypotenuse. So let's fill in the information out. Well, we still don't know the angle. So sine theta is equal to O was 9 centimeters. H was 18 centimeters. And if we solve this now, if we just solve this, sine of theta is equal to 0.5, which is equal to 0.5 because the centimeters cancel out. Okay? So the final step now, very well done if you figured this out, we have to do the opposite of the sine function. And what that means is that theta is equal to inverse sine, so that's the sine minus 1 of 0.5. And if you did that in your calculator, so that's shift sine 0.5. If you press go, you find that the angle theta is equal to 30 degrees. So very well done if you got that right. This is the hardest type of trigonometry question you could be asked because you have to use the inverse function, okay? So very well done if you got that right, and we'll see you next lesson. Bye now.